Hey guys, welcome to my new video. Sorry it's been a while that I put out a video, but there's kind of reasons behind that, and I don't want to really go into that right now. But if you're new to this channel, or if you're just not sure what I'm claiming here, is that in modern science, they've been telling us since grade school that the Earth is made by gravity, and that it starts out as an accretion disk, and that particles slowly accumulate over time to build up this huge, complicated planet system called Earth. And it just doesn't really add up when you think about it, because the Earth is complicated. If it wasn't complicated, we would have figured it out by now. But, when you think about it, it doesn't explain the continents. It doesn't explain how we have different types of matter, and it certainly doesn't explain how life was created on this planet. It really just leaves a big emptiness in our knowledge. What I'm claiming is that if the planet wasn't created by gravity, let's say that it was created by a source located in its core. At one time, the core would have been the planet, but now that it's maybe creating the planet, it's sitting at its core. And if something like this was true, then the planet would have images embedded in its surface that would reveal this. It would be revealed as reoccurring images over and over again, because it would be the source of its creation, if you think about it, right? And if you were to pay special attention to the features around the reoccurring pattern, you could actually probably put together the images and actually either see it or visualize the whole process in motion. And that's what I'm saying, that if we pay close attention to the surface features around the planet, we can actually witness exactly how the planet came to be and figure out what caused it. Now, if I was able to show you that there are reoccurring images embedded in the features around the planet, that would be strong evidence that what I'm claiming to be might be correct, that the core of the planet is what makes the planet, or the source of energy, or the dynamo, or whatever that's located in its core is responsible for the surface features. And basically that's all I'm trying to do, is that over the last 4 years, as I've been showing you, there are images that look like one another, and I simply overlay them to show that they are related. And because there's so many of them, this only makes sense that this has to be something that's internal of the planet, not external. I'm a strong believer in the electric universe theory, and I do believe that the planet is related to electrical. That it's somehow electrical is what made it, it created it. The difference between what I think and what the electric universe thinks is that they're claiming that the external features of the planet are the result of external events of electrical. I'm not saying that they're wrong, but what I'm saying is that these reoccurring patterns cannot be from external events. That has to be internal, or they'd be random. There'd be no matching going on between features like this Tarim Basin, this what looks to be like a gouge. This is basically where it all starts, in my opinion, for me. This is the most obvious feature on our planet that sticks out like a sore thumb, and it's hard to ignore, especially when you got next to it these seas that are about the same size, but they look as if they're rotating away, because you got this one here at that angle, and then you got this at this angle. You got a 90-degree angle here of gouging, and then you got something here that looks like it rotated completely around. I'm claiming that these are related. It only makes sense, but it doesn't just relate by gouging. There's also then patterns embedded in the features that are also very similar to this gouge. So what I'm claiming is that what made this gouge, and obviously is spinning and rotating and made these seas, is also responsible for surface features that are not gouges, like this. You can see that they look a lot alike. But then it gets more complicated because some of the features look alike, but they don't look alike, but they still match up. You would see that in features right next to it, like this right here. This is similar in size. It looks nothing like that, but if this, what made this sat underneath this, and this is molten material spinning around this gouge, you can see that these little lines of probably mineralization seem to match up with these features here. And you can kind of see that this is similar in shape. All I want to do is to show you, I want to make this as simple as possible. My job today in this video is just to convince you that there are reoccurring patterns on the planet's surface feature, and that this might be because they are images of what made the planet. Like I'm claiming, it would be embedded all over the planet. You can see that just there's similar sizes here going on. Like right here where I'm circling, like that, these are all similar in size and width, in which it all comes down to this, what looks to be like twisting. And this is where I think that the electrical comes into play at the core of the planet. This is spinning and rotating, and these are just imprints in the surface of what happened at the core, probably as the planet was increasing in size. That's what I'm claiming. Let me get started by showing you now what these images look like when they're overlaid on top of one another. Okay, first I want to start off with the most obvious reoccurring pattern, is this tarn basin, which a basin, when you look at it, it looks more than a basin. It just, when you look at it, it looks to me like gouging. Something had spun and gouged this out in the middle, and might be the cause of all the sand. When you think about it, would not gouging, electrical gouging, create a byproduct of sand? In mainstream science, this sand here is the result of water, wind, and erosion. But that's a lot of sand. And where did it erode from? And when you think about it, Mars is covered by sand and sedimentary rock, yet there's no water on there. Not enough to do any of this. And yet Mars has more sand than Earth. It's covered with it. Maybe water has very little to do with sand and erosion. Maybe it's just a small piece of the puzzle. And maybe the bigger piece is electrical scarring and gouging. I mean, you can literally see that something spun, and you could just see that this is the turbulence around it. You can see the crisscrossing here in the patterns, which tells me something is spinning, rotating. It looks very much like Birkeland currents. If you don't know what Birkeland currents are, you should probably look them up on Google, and you'll see that they look just like this image right here. So anyways, I'm going to start off with this as my template of reoccurring patterns, since it's the most obvious. And how I'm going to do that is I'm simply going to take straight on shots of this image, and then I'm going to take straight on shots of the reoccurring patterns around the planet, and then I'm going to simply overlay them so you can see whether they are the same size or if there's any relationship between the features on one another. It's that simple. Then I'm going to leave it up to you to think whether they are related or if it's just a coincidence. Okay, here you can see Earth shots of the Tarn Basin on the left and this feature right next to Papua New Guinea on the right. And what I simply do is just simply make one transparent, and then I overlay them to see if they match the size and shape. And I'll zoom in, and you can see that they do. But the thing is, you got to remember that what I'm claiming is the process at the center of the Earth is making these reoccurring patterns is in 3 dimensions. It's a 3-dimensional spinning process. So what I'm showing you here is a 2-dimensional surface feature. And because it's a 3-dimensional process, one of these images could be the back side, or it could be the front side of what made this. So some matches are going to be really good, and some matches will be a little different from one another because they could be the side of this, or the other side, or the reverse, because it's the back side. So with that said, what I do is that I look at it and I try to match it up, and then I'll flip them around and see which matches the best. But I think both will match good. What's interesting on a side note is that when I simply move this over, you can see the features also resemble the areas around the Himalayas, as if this is moving away. Like that. It's kind of interesting that this area, if this wasn't flattened, this looks like a collapsed tube. You can see the molten material obviously flowing over what was underneath here or around. But then if it came to the surface, it may have been flattened down. And you could see that that kind of story is playing out also here. You can see the material overlapping this stuff underneath. It almost looks like stuff is shooting out or being sucked in. And then when I simply move them, to do this the right way though, I need straight on shots of these areas, and when I do that, they usually match up even better than these ones that are off. You can almost tell that the features underneath are resembling some of these features above. See how it just plays into it? This ridge seems to form along the discoloration of the features below. And then it's almost like these are just an evolutionary process of the images swirling around what gouged this out. Let me flip this around and show you what it looks like the other way. See this Australia's here, over here it's here because this is spun around. What's interesting is that when I match this up, you can see they're very similar in size, this inner feature. But what's interesting about this is that this turbulence, this crisscrossing here, looks like something that was spinning through in turbulence. And then when you look at Papua New Guinea, it gives the impression of twisting too, with the arm coming out this way and the crisscross. And when I line them up, you can see that for some reason it just kind of looks like it plays into it a little bit. What's interesting is when you look at India, you can see that it looks a lot like this feature right here. I've shown this in other videos before this, and it's really complicated, and I want to keep this video simple. But if you're interested in the more complicated alignments, then watch my previous videos. Okay, the next reoccurring pattern I want to show you is right off this peninsula off of Antarctica, and this is a big one because this is obviously closer to the inside of the process that created these reoccurring patterns. So this one's going to fit a lot of things. And as you can see, it fits in there. Not only does it fit, though, you can see that this point and this point look a lot alike. and you can see the scalloping is matching here. Perfect. As if this is moving through. You can see this arch right here is related to that scallop, and you can see the scalloping. And the other thing about that's odd is this scalloping is the same size as these features that twist here, that crisscross. What a coincidence, right? Wouldn't that make you want to think that these are all related? But like I said, that this process is spinning. What also is interesting that I've noted in other videos is these ridges here on top and below are the same distance apart as the ridges by the Tarim Basin. Another coincidence with this feature that's the same size and same width and the same scalloping of twisting. And like I said, twisting, so let me flip this around and show you what it looks like the other way. You can see the scalloping here again, matching the features. Everything's matching because this is a two-dimensional image of a three-dimensional process. Look how the crisscrossing, these features, this turbulence next to it also matches in size and width and twist. It's just another coincidence. Look at how this ridge just kind of resembles this. This triangular point looks a lot like the triangular point by the Himalaya mountains. It too is similar in size and shape. See? The twisting. The Himalayan mountains are believed to be the result of a collision, but I'm claiming that the Himalayan mountains are the result of twisting from the planet's core. But what happens when I bring in the other reoccurring pattern that I had lined up with the Tarim Basin that's next to Papua New Guinea? What happens if I take the same feature by Antarctica and then simply slide it over and line it up there? You can see the scalloping is very similar to the features also below. The crisscrossing. And what happens if I flip this around? Well, it matches again, and it actually looks a lot like these features around that reoccurring pattern. The crisscrossing is if it was moving through, the process that made them is moving through. See how they're the same size, same width of this inner feature. It almost looks as if you could rotate South America and it would fit into here. But all of these features are related to this, so it gets complicated when you do that, because this is actually the reason I'm claiming these other areas are even there. Okay, so what happens now if I take this feature that I just showed you by Antarctica and I match it up with this feature right here up in Russia, not far from Alaska? You could see that they are similar in size and shape, except for, remember, I mentioned that this process took place at the planet's core and it's three-dimensional. So what happens if I take this and I spin it around? Because it doesn't matter how it matches, as long as it matches is all that counts. Like that. You can see that these features are the same size and same shape, with the scalloping here and this feature right here being the same distance and width. Look how they match up. This twisting, again, looking as if it's responsible for the scalloping. This twisting right here that I'm claiming, this is twisting. The crisscrossing, this is a really complicated image of crisscrossing, but it sure seems to be related to these features on the side, as does this. So I'm just asking you, are these the same, similar size and shape? And might that be that they're related? Because what are the odds that you'd have something this huge on the planet matching over and over again? And then what happens if I flip this upside down? You can see that they still match up, especially with the scalloping below. Might this be corkscrewing and spinning around? The process that made both of these images. When you study these images, it gets so crazy. You can start to see alignments like here, right? The turbulence. Matching up as this scalloping starts to match this way. Remember, all I'm trying to do is show you that on the surface of our planet there are reoccurring patterns, and that something had to have made these reoccurring patterns. And it has to be something internal, not an external event, because these would not have reoccurring patterns if they're random events that happened externally. It's just kind of logical when you think about it, right? Okay, so what happens now if I take that same image by Russia and show you what it looks like matched up with that area by Papua New Guinea? You can see that they look alike. They're the same size, again, the same width, and the twisting. And it might even rotate. Look at these features, how this look like they're related above it. You got the points. And what's interesting is that some of these reoccurring patterns may be bigger because they may be going around the outside of something that's smaller in diameter. So there's all kinds of variables that could explain why things aren't exactly alike. Like this. This looks similar, especially if I rotated it. Okay, on the left here there are two new reoccurring patterns that I haven't shown yet, and I'm going to quickly go through this because you should be getting the point by now that this right here and this right here are relatively the same size and shape as this feature by Antarctica here on the right. And you know, this one's kind of a little bit hard to see, but you could tell that they're very similar in shape and size, and it even curves around like the image below. You can see that, and then you can see that if I bring this in here, you can actually see that the twisting here is a lot like the boot on Italy, the texture of the mountains. And you can tell that this flips around and this point would line up with here. I dimmed it out a little bit so you can see that. Let me pull this out. Alright, see how this texture fits with the mountains on Italy? Alright, so I just wanted to show you that because I want to get to the next image. I can go on and on and on and show you these. There's other reoccurring patterns that fit all this too in other areas around the world, but these are the most obvious, and I wanted to go to the next thing to show you that, you know, I made a claim in the beginning of this video that the images of the planet's creation would be embedded in its surface if its creation process took place at its core, and these images would have been spread around as the planet increased in size, because it kind of makes logical sense. Well, if this is true, then the process should be embedded somewhere that made these gouges and areas that match up. And that's why I want to take you back to this image of the Birkeland currents, this daisy chain looking image on the left, and then on the right you can see what is causing that. Well, are these images also embedded in the surface features on the planet? They would have to be if they're related to its creation. So let's take a look at that. And up here by China, next to the gouge, you can see that daisy chain image right there, the crisscrossing. This, I believe, is from Birkeland currents. You could just see it in the images, but this isn't the only one. If I back out and I roll the planet over here to South America, you can see that there's these filament looking mountains here. They look like rope. They look like they're twisted, and under closer inspection you can see that that's the case. You can see that you got this filament range, whatever, slopped up on top of this one below. You can clearly see that this is going underneath, and because it's at the surface it's been flattened. But at one point it wasn't. When it was sitting at the core, these were obviously twisting around one another tightly, and you can see where when they do, you can see the electrical discharge patterns everywhere. You could see that the massive amounts of electricity was released when this was going on. You can see that this is diving and it's going under here and it disappears. You can even see pieces that have broken off. You can see where it's come apart. But ultimately, the main thing is you can see that this is going underneath this, and there's, in my opinion, there's nothing in plate tectonics that could explain why that would be like that. This couldn't be a lava flow. You can clearly see the clear-cut line. What happens when I start lining those up? You can see that here I have that area by the Tarim Basin, and then I have that area in South America. And to be honest, I think that you should do this on your own. I don't think you can appreciate these alignments unless you do them on your own computer in front of your own eyes. Okay, I took out the oceans. I'm trying to make it a little bit easier to see. But you can already see that the Birkeland current images are matching one another when I just bring them in like that next to each other. Let me take the color out, might help. Okay, hold on. Let me change the contrast. Okay, so you can see this is kind of hard to see, but let me try it the other way. Okay, here's the same images, but this time I'm taking the other one and making it transparent. There seems to be no easy way of doing this, but just look at these two areas here on South America here, and then by China with the Tarim Basin. As I bring them closer together, this is really hard to see, but you can see that they're related. You can see that it's really hard to see, but you can see this right here, and then if I look at it right here, you can see this is very similar in shape and size, but the twisting here also matches this mountain, the filament looking mountains that crisscross. It's just so hard to see. Hold on. Alright, so I don't know if you guys can see that, but they match up. It just sucks that I can't get it to be easy to see. You can even see the, it just matches as if it is going through. Actually, it just matches really good right there. The fact that they're the same crisscrossing size tells a lot. But this video is running long, and I just want to take one more image that I want to show you guys. Now, I've showed this before, but it's worth showing again. And in this video, I have made claims that images of the planet's core are embedded in the surface features as reoccurring patterns, and then, which is the simple part of this. But then you can take it up a notch, and you can see that what makes the reoccurring patterns here also has a reoccurring theme, and this also replays over and over in images around the planet. But such a complicated image shouldn't match up to North America like it does when I put it together here, unless there's a relationship. I mean, look, you got this arch and you got this V right here, and then you got the California Basin, but you also have the turbulence here, this line matching features on the coastline. See? But what's even more amazing is it matches not just there, but it also matches in further, because if you look at North America, you can see what looks to be like a feather. It just has the image to it, right? Well, if you look at the same feature over here, you can see what looks to be like a feather image. And the reason I'm showing you this is that if I bring them together like I have, just like this, it matches perfect. But as I bring it in, the feather also matches the turbulence here. They're just matched. You can tell that they're related. As this ridge matches the features too below, you could tell that this is almost as if it's crunching in, like, or it came out, if that makes any sense. What are the odds that such a complicated image is going to match up as I bring it in? Look, I bring it in, it matches there, but also these features here seem to match up with the features also with the California Basin. See how it matches the coast? the mountains here on the ocean floor. It's almost as if this is rolling out or something. Anyways, I wanted to leave it on that. That's a complicated image. There should be no relationship between these two. And then I've shown in other videos that this also matches other features around the planet. And what's trippy is that sideways V looks a lot like the tip of South Africa if I was to get the proper sizing and rotate it in. Right here and here. It's because they're all related to the process that made them. Thanks for watching. I'm sorry this video was so long, and I want to thank the people that have been supporting me all along, that still watch my videos and still are subscribed to me. I really appreciate that. There'll be more to come. I want to make something, you know, really amazing for you guys, so I've been taking a lot of time off and thinking about this stuff. So anyways, thanks for watching. Bye.